Okay, on to the next word problems. These are related rates questions. That means that you will get a lot of pers in the question. Kilometers per hour, meters per second. Let's check this first one. Oh, there's a meters per second. And you're going to have to find some sort of formula that links the related rate that you're given, or related rates that you're given, to the related rate that you're looking for. So when you do a question like this, it means that you've got one rate affecting another one. So in the example that I've given here, which is, I believe, a circle question, the rate that a radius grows will also change the rate that the area or even circumference of a circle grows. So that's an example of rates that are related. Oh, right here. These changes are called related rates because they are rates that are related. Again, it is a place in math where somebody labeled things appropriately. So to find the rate of change of a related quantity, you have to find an equation that relates the two quantities. These are usually formulas that you should be familiar with. If I give you in class the success criteria sheet, it will have all the formulas that you need on it for this unit. So I will try to remember to attach that to the Google site. You need to find the equation, and then you need to differentiate. So take the derivative, go figure, it's calculus, of both sides of the equation with respect to time. So that's a bit different. Maybe asking yourself, how do I tell the difference between these questions and the max-min questions? And the answer is, it's kind of easy, because if you read this question, actually the question part of it, find the rate of change of area, blah, blah, blah. At no point does it mention maximums or minimums, so you're not optimizing anything. So that means you're not taking the derivative, making it equal to 0, solve. So you're not in that position. So let's try question A. As it says here, the examples are from the booklet. So there is a booklet on the Google site. And this must be number 5, so you don't have to write it down if you don't want to. A pebble is thrown into water and causes a circular ripple to spread outward at a rate of 2 meters per second. So what I like to do for these questions is I like to write down all the stuff I have. So I now have dr by dt, the change in radius over the change in time. So because it's spreading outward, it's a positive 2, and it's meters per second. And I tend to always write down the units so I don't have to reread everything. Then the question says, find the rate of change of area. So we're looking for dA by dt. In terms of pi, meaning we want pi in our answer. And the question says 3 seconds after the pebble falls into the water. So the first thing you have to do is you have to come up with a formula that links R's and A's. And that should be quite easy. It's the area of a circle formula. Then you take the derivative of both sides. And it says, with respect to time. Now what that means is that this looks a little bit different. You take the derivative of A, which is 1, and then with respect to time looks like this. So it's sort of like implicit differentiation. Then this side is drop the 2, keep writing, make it a 1. And this is the R side of the equation, so it's dr by dt. I'm going to take out the 1. I need to know what dA by dt is, so it's going to stay an unknown. My 2 is going to stay a 2. My pi is going to stay a pi because I want it in terms of pi. My R is unknown for a minute, and my dr by dt is 2. Now, how do you find the R? Because without it, you can't actually solve the problem. And it is, if you think about it, if this story is happening for 3 seconds, that means that to find the R, you're going to take the 2 meters per second times 3, and you end up with 6. and you get a value in there. So dA by dt in terms of pi, so keep pi as pi, is 2 times 6 times 2, which is 24 pi. And then we can write a therefore statement that says, therefore, the area is growing at 24 pi meters per second. Now you got to think about this for a second. Area is not meters, it's meters squared. So we have to make that little adjustment. So I'm going to take a break because I think I hear some water leaking across my house. This is so weird. Nope, just an old house. Creaky floors. All right, next question, which still relates to this question. So, because this is where I kind of cut things off before starting A, that means this piece of information and this piece of information can get redone. So I still have a radius change of 2 meters per second. I still am looking for the rate of change of area with respect to pi, meaning pi has to be in the answer. So this one's a bit trickier. But you have to think about what you have versus what you need. So the first thing I'm going to do is the same thing as I did the last time, and that is get a formula that relates A's and R's. And then I'm going to take the derivative of it, same way as I did before. Difference is I left out the 1 this time. And now I'm going to put in some values. So 2 pi, dunno, times 2. dA by dt is dA by dt, because we don't know it, and that's what we're looking for. So here's the problem this time. I haven't used this piece of information right here. And I need an R. So this is actually an area. So if I steal the area formula again, and I put 9 pi in where the area is, because it says that the area of the ripple is 9 pi meters squared, I should be able to isolate my R, and when I isolate my R, I can put it in here. So I'm going to divide both sides by pi, and have 9 is equal to R squared. So R is equal to, still practicing the plus minus, even though I know that my only acceptable answer is R is equal to 3, rather than negative 3. And then I can continue the problem. So keep pi. 2 times 3 is 6, times 2 is 12. So therefore, the area is growing at 12 pi, and again, meters squared per second. Area, time. Area, time. Okay, next questions. Woo. I'm going to make a new sheet, assuming I need to for each of them so I can spread out. Okay. All right. Number 2 from the booklet, under circles and spheres. So let me generate my little list based on the words. It says a spherical balloon is blown up so that its radius is being increased at 3 centimeters per second. So that is dr by dt, radius. It's increasing, so I don't need any negative signs. How fast is the volume increasing? At the instant, the radius is 5 centimeters. So pers get dr by dt, or dv by dt, or dA by dt, or something by dt. And facts just get a letter. So this time, we're going to need a formula that relates volume and radius of a sphere. So that is, volume is equal to 4/3 pi r cubed. Take the derivative, 1 on this side, and then dv by dt. That'll be 12 over 3 pi r squared dr by dt. And hopefully you can do this in as many or as few steps as possible, because 12 divided by 3 is 4. And now we can put in the values. So dv by dt is our question mark, staying unknown. 4 is 4, pi is pi, r is 5 squared, dr by dt is 3. So my final answer, and I'm going to keep it in terms of pi, even though you're welcome to turn pi into 3.14 and use it as a decimal. This is 25 times 4, which is 100, times 3. So that's 300 pi. And to reread the question, how fast is the volume increasing? Fast is a per. So therefore, the volume is increasing at 300 pi centimeters per second, but volume isn't centimeters, it's centimeters cubed. And there I have my answer. All right, next one. And again, I am going to make a new sheet. And I kind of remember that when I had them listed, although it's not numerically correct, I'm doing 13 before 11. Okay, a snowball melts. Okay, so this is a little bit different. A snowball melts so that its surface area decreases at a rate of 0.5 centimeters squared per minute. So red pen, surface area, so not side, I made it a big S, not that it matters what you use. And because it's melting, I'm using negative 0.5 centimeters squared per minute. Find the rate at which the radius decreases. So I will expect a negative dr by dt when the radius is 4 centimeters. So again, I need a formula that links surface area to radius. So the surface area formula for a snowball, so a sphere, is 4 pi r squared. So when I take the derivative of the left-hand side, I'll get 1, and then ds by dt equals, drop the 2, 8 pi r to the 1 dr by dt. Plug in the values. So this is a bit different as well. I get to put a value on the left-hand side, also a value on the right-hand side, but I'm looking for dr by dt, which is in this whole mess of stuff. So negative 0.5 equals 32 pi dr by dt. I need to get dr by dt by itself, because that's the object of the question. So I get to divide both sides by 32 pi. And it is very important how you write your answer. So I'm going to do some weird stuff here. First thing is, this pi has to stay looking like it's in the bottom. So if you're a slashy fraction person, I'm not going to be able to tell what this means. So you will have to put a bracket around that. So extra writing for those of you who continue to slash your fractions, as opposed to stack them like I've done here. You have to make it perfectly evident that the denominator is where the pi is lying. Now the other thing is you can turn this into a decimal if you like. You can take 0.5 and divide it by 32 pi, the whole thing. But what I'm going to do is I am going to multiply this by 2, because that'll give me -1. And if I multiply the top by -2, I have to multiply the bottom by 2. And that'll give me 64. Pi still remains in the denominator. And there I have my answer. So unfortunately, I have forgotten exactly what the question is about. Find the rate at which the radius decreases when the radius is 4 centimeters. So I can write one of two therefore statements. And this is very physics-like. And you have to be very careful about your language as well as where you put your pi. So one of the two therefore statements, you can say therefore the radius is decreasing, so a directional word at, and if you use a directional word, you have to take out the directional symbol. So we'd have to say 1 over 64 and keep it positive, and radius is centimeters, time is seconds. Now, if you didn't want to do that, you could say something quite boring and directionless, like the radius is changing, which doesn't tell me whether it's going up or down. I'm going to say by. And this is where you have to put in the negative to say how it's changing, as in the direction it's changing. So if you use a directional word, you take out the directional symbol. If you use a directionless word, you put in the directional symbol. All right, last question. Time for it. A spherical balloon is being filled. Okay, so usually this means we don't really have to worry about direction. It says a spherical balloon is being filled with helium at a rate of, so I've got a d something by dt, 9 pi centimeters cubed volume slash seconds slash dt for time. How fast is the radius increasing? So dr by dt is the question mark, and the time is equal to 4 seconds. Not that that helps me with much yet, but I'll have to build it in like we did with that first question. So, formula. Volume and radius for spheres is back to this one. And take the derivative, so that's 1 on the v side. And 3 times 4 is 12, divided by 3 is 4 pi r squared, the r side. So I did that in less steps than I did in the second question, I think it was. Put in your values. 9 pi, 4 pi. I need something here because the only unknown I need is the dr by dt. So we have to do what we did in the first question, and that is, this is going to be harder. That is, if this is 4 seconds, the volume will be 4 times 9 pi. So the volume is 36 pi. But that doesn't tell me the radius that I have to drop in here. So I have to use this formula, 4 over 3 pi r cubed is equal to 36 pi. And I have to undo everything and get the r by itself. So that means I'm going to times both sides by 3 to get rid of the divided by 3. So that's 8. It's 108 pi. I have to divide both sides by 4 pi. So I see good in that because my pi's will cancel out. So on my left-hand side, it's r cubed, so I'm getting closer to having an r value. And on this side, it's 227. Oh, that works out nicely because I am going to cube root. Remember, don't worry about plus minusing with cube roots. 27, and I get an r of 3. That worked out. I just had to persevere. So, back to actually finding this. So I hope you see a benefit of a list to find out what it is that you're missing if you're missing anything. So 9 times 4 is 36 pi dr by dt. So this is one where we're going to have to do a little extra math. Divide by 36 pi. Divide by 36 pi. Unlike the last question, you do not have to worry about where the pi is lying in your fraction because these pi's will cancel out. And you'll be left with 9 over 36, which you have to reduce because you can. If you feel like writing 0.25, you can totally do that. Question was, how fast is the radius increasing? Therefore, the radius is increasing at 1 over 4 centimeters per second as opposed to centimeters cubed per second. And there we go. So part of the problem with this unit is missing information that you have to think outside the box to try to find so that you can actually solve the problem. All right, so the stuff in the booklet, notice that it's not the questions that we just did, but it's in the circle and sphere problem area, and I will be back at some point to do cylinders and cones. All right, there you go.